All right, for this last video on the linear functions review, we'll look at problem number 7 that says you're driving down the highway and step on the gas. After 1 second, your speed is 40 miles an hour. After 5 seconds, your speed is 60 miles an hour. You accelerate your car so your speed increases linearly. Part A says sketch a graph of your speed versus time. Be sure to clearly label each axis with appropriate variables and units and to indicate which scale you're using. Okay, so I've gone ahead and included our axes up here above, and I'm labeling the horizontal axis as time, and I'll use the variable t there, and t is measured in seconds. And the vertical axis is our speed, and I'm going to go ahead and use v there, v for velocity, and plus my s's look a lot like fives. Okay, so that's measured in miles per hour. And now since we know that after 1 second our speed is 40 miles per hour, we can plot the point 1 comma 40. And after 5 seconds our speed is 60 miles per hour, so I'll plot the point 5 comma 60. And since it says we're accelerating our car so our speed increases linearly, I'm just going to draw the line between those 2 points. So I've gone ahead and done that here. And so this is our graph of our speed versus time. All right, part B says to determine the slope of the line, being sure to include appropriate units. So I want the rise and the run. So as I go from this point 140 to the point 560, okay, my time is increasing from 1 to 5, so that's a change of 4 seconds. This is our run. And then the rise here, the vertical change, we're going from 40 miles an hour to 60 miles an hour, so that's a change of 20 miles per hour. Okay, so now go ahead and simplify. 20 divided by 4 is 5, and the units here are miles per hour per second. Okay, so the units there, this is an acceleration. It's telling us how our speed is changing over time, and we're saying that for each additional second, we're increasing our speed by 5 miles an hour. All right, now C says find an equation for your speed v in terms of t. All right, well, we know our slope here, m is 5, so we know that v is equal to m, which is 5t, plus the y-intercept b. And it looks like b is about 30-ish. I mean, it's a little hard to eyeball from this graph. Maybe a little bit more than 30. Let's go ahead and just plug in a point to find b. So plugging in, let's say 140. Okay, so set v to 40 and t to 1. Yep, it's going to be 35, right? Because this is 5 plus b. And so if I subtract 5 from both sides, I'll get that b is 35. Okay, so this is the point 0, comma 35. And so putting all that together, our equation for our speed in terms of time would be 5t plus 35. All right. Part D says determine your speed after 8 seconds. Well, that's just going to amount to plugging in t equal to 8, right? So go ahead and do that here. So I'm going to multiply the 8 by 5 and then add 35. And so this is 40 plus 35. So that's going to give us a speed of 75 miles per hour after 8 seconds. And then lastly, E, it says, after how many seconds will you be traveling with a speed of 50 miles per hour? Okay, so I'm going to just set now v equal to 50 and then solve for t. So 50 is equal to 5t plus 35. Go ahead and subtract 35 from both sides. And that's going to give us 15 is equal to 5t. Divide both sides by 5, and we see that t is equal to 3 seconds. And notice we can also see that up here in the graph. If I increase my speed by 20 miles an hour in 4 seconds, then in 2 seconds, so in other words, in half this amount of time, I'm going to increase my speed then by 10 miles an hour. And so I'd be increasing my speed from 40 to 50 in 2 seconds past 1 second. So yep, 3 seconds makes sense. All right, that's going to do it. Thanks.